Hello everyone. With Adrien GIRARDOT, we are going to present you an experimental project around the optical properties of dental materials. Next slide, please. Adrien, can you move?
Sorry.
Okay, thank you. So we worked on the special resin dentists use to dentists apply on broken teeth to repair them. For aesthetical purposes, it is important for the optical properties of this resin to be as close as possible as the one of the broken teeth of the patient. And in order to achieve this color matching between the two materials, most of the dentists today use shade guides, which won't take into account the fact that the perception of the color of a teeth depends upon the current illuminant in the room. And therefore, it is necessary to develop new methods to characterize and to measure precisely the optical properties of this resin. And this was the goal of our project. Yes, you can. Yeah, thank you. So now I will describe more precisely the specification we established and the setup we construct to fulfill them. So we have decided to limit our study to the transmittance. And we wanted to record the scattered light by the sample, the light scattered by the sample at each angle and for different thicknesses. Thus, we use a tungsten lamp to illuminate our sample and a camera on a turntable to record the intensity scattered by the sample at a measurable angle. So with this setup, we obtain a figure like the figure 1, which is a plot of the intensity of the spot received by the camera, of the image received by the camera, as a function of the angle of observation. On the animation below, you can see the series of pictures taken by the camera from which we extract our measurements by making the sum of the intensity of all the pixels. Okay, so after recording our data like this, we have to make some data processing to improve the signal over noise ratio of our measurements. So the first thing that we did was a thresholding to get rid of a part of the noise. And then, because the light wasn't scattered enough by the thin sample, we have to increase the exposure time with the angle of observation to be able to record a signal. So modifying the exposure time during the measurement is called, it's a technique that is called a high dynamic range technique. And so it is well shown in the animation at the right. So on this animation, you can see the spot is the spot flash. And each time it flash, it means that we have increased the exposure time. So with this technique, the raw data we obtain is presented on the figure on the top at the left of the animation, and we have to do some process to stick back the pieces and obtain the final smooth curve below.
So our results are presented on the following figure. So we studied 3 different samples with 3 different thickness, the thinnest that we had and the thickest, and one between those two. So as you can see, the profile is very different. And then we had to find a model that can fit those profile. So we used the curve fitting toolbox of MATLAB. And so as you can see, for the thickest sample, the Thermosine fits pretty well. For the middle thickness sample, the Laurentian does not fit well, but for the Gaussian, this is much better. So we can think that the model for this one is a Gaussian. And for the thinnest, it's more a Laurentian that fits very well, or data. So as you can see, the model is different on the thickness, and we didn't find a model that fits well on all the samples. And finally, we made uncertainty measurements. So for 4 different angles, we made 10 times each measurements. And between those measurements, we move the sample. And as you can see here, the uncertainty is shown by those horizontal bars. And the uncertainty is very low compared to the difference between 2 samples. So our measurements are very repeatable. So to conclude, we can say that we managed to obtain a repeatable angular measurement of the transmittance of those dental materials. And we found that it's a combination between Lorentzian, Gaussian, and sum of signing model that is necessary. And we couldn't find a model that fits all those samples well.
Okay, and to go further, we can mention that it can be interesting to study the reflection by modifying slightly our setup, and that it can be interesting to do a more intense HDR technique to study the halo around the spot on the images recorded to the camera. We can also mention the fact that the angular results that we obtained during this project might be used to construct later a radiative model to go further on the prediction and on the understanding of the properties of dental resins. This can be done especially in the framework of the thesis of Vincent Duvillier, which aim at generating a model to predict optical behavior of dental resins. So thank you for your attention, and if you have questions, we will be happy to answer them.